Hello everyone, my name is Caitlin Bourne and I'm going to walk through the 4-bit microprocessor. I've started the simulator and it has the clock tick continuously flowing into the counter, and the counter flows into the PROM. And basically the PROM holds the entire instructions of the program to be ran throughout the processor. And the PROM outputs two 4-bit numbers. Bits 0 through 3 flow into the multiplexer, and bits 4 through 7 flow into the instruction decoder. And the instruction decoder, its entire purpose is to translate the instruction code it has received from the PROM, and it outputs the address into the microprocessor where the instructions can be sorted out thoroughly and accurately. The instruction decoder, as you can see, flows out into a splitter consisting of 7 binary bits, and every binary bit has a specific purpose. It was given in the instructions. Basically, bits 0 and 1 flow out into the register file and into the write enable and the address. Bit 2 flows into the display, write enable. Bit 3 flows into the register file source input selector. Bit 4 flows into the ALU, the write enable output, and bits 5 and 6 flows into the selector bits within the ALU. So let's take a look at our inner workings of the 4-bit microprocessor. As you can see here, this is the ALU. It should look pretty familiar from previous labs. We have an AND, bitwise AND, we have a bitwise OR, we have a bitwise XOR, and a 4-bit full adder and subtractor, which I'll get into in a minute here. That flows into our multiplexers, and that flows into the 4-bit register, which is made from a 1-bit register, as you see here. And then we have a clock and we have a write enable, pretty much determining what goes through and what doesn't, and flows out to these outputs. Here is the data multiplexer we have created. It's not much different, not different at all from the ones we've had to put together in previous assignments and labs. So it should be familiar to you. Here we have the register file, and the register file consists of first of all, a 1-bit register, which we talked about previously, which consists of, which makes the 4-bit register, as you can see here. The first input flows into the register, and the clock is connected to the clock. The load is connected to the load in the 1-bit register, and so on and so forth. So let's go back to our main component here, and let's talk about the code that we had to enter into the PROM. As you can see here, what we needed to do is to implement the software subtraction. So we had to implement it right here, and so basically it'll load the first number in, and it loads in the first full 4 bits, performs the XOR function that I showed to you in our subtractor, and then actually I didn't show you the subtractor, so let's go look at that real quick. Let's see, where is it? There it is. Okay. So what makes this different from the full 4-bit full adder that we implemented, we used in the ALU lab originally, is, we have the adders here, the 1-bit adder. Oh, and as you can see here, in order to implement the subtraction aspect, we implemented the XOR gates. Basically, the XOR gates perform the function of 2's complement. So it takes one, it'll load the first number, it'll load It'll add 1, then perform the exclusive OR 4-bit on the second 4-bit, which turns into 2's complement, then adds it to the other number, and it performs the subtraction. Back to our code. So basically, this line takes, kind of similar to what I just explained, software implements software subtraction. It'll load the first number, as we said earlier. It'll load the first number, the first full 4 bits, perform the XOR function, then takes 1 and adds it, and then it loads it back into the first register. Then it loads the next number into the second register, and then adds it again to display it as a number. So that's about it. Thanks for watching.